Hi guys, welcome to NEET world of NSEJS class. So in previous sessions of NSEJS, we have discussed about the PYQs of the last year papers of NSEJS, right now. So in this session also we are going to continue with the PYQs of NSEJS, which is for class 8th, 9th and 10th. So let's start with the question of this session. A tube of a uniform cross section contains two different liquids in its limbs, they are saying. Okay, in its limbs in the sense in the tube, okay, namely water and mercury. So water density is 1 into 10 power 3 kg per meter cube, whereas the density of the mercury is 13.6 into 10 power 3 kg per meter cube as shown in the given figure. Okay, the difference of height of mercury column in two limbs of the tube is h is equals to 1.5 centimeter. Note the point. So they have given the the difference of height of a mercury column. Okay, mercury column. So it is h is equals to 1.5. So h is equals to 1.5. What is that? Centimeter. So everything is in centimeter. No, I need to no need to convert anything in meter. So everything is in centimeter, like options I am saying. Okay, the height of a height h of a water column in the left limbs above the mercury column must be nearly. So the thing is, in a U tube, no, like not U tube, okay, this U shaped tube, okay, equilibrium, pressure at the same horizontal level in both limbs are equal. That's the thing we know, right now. So this side pressure, that is water pressure, should be equal to the pressure in the the mercury side. So what I can do? So pressure due to the water column of height h must be balance the pressure due to the mercury level difference h. So I can write like this now. Density of water G h small h no, should be equals to density of mercury, I will write M into G capital H. Fine. So in this case we know that G and G can be cancelled. So I need to find the value of H, that's the thing. Should be equals to density of mercury by density of water into height H. So what is the density of mercury is given there? Density of mercury is 13.6 into 10 power 3 and water is 1 into 10 power 3. Okay, let me substitute the value. 13.6 into 10 power 3 divided by 1 into 10 power 3. What is the value of H? So the value of H is given 1.5 centimeter. 13.6 no? Yes. So 1.5 centimeter. So into 1.5, where 10 power 3 can be cancelled out. And here 136 into 15 divided by 100 I have taken. Okay, done. So from this I can cancel or I can multiply directly, I can get the values. So 136 into 15, right? So 33 and 15, 8, right now, and 15 no, and 18 will come. So 5, 6, 680, done. Plus this is 6 as it is, right now, 3 and 1, done. So 0, 4 and 1, 0, 20, 40, is that correct? No, 20, 40. So divide by 100. So 20.4 centimeter, I guess. So option is there, 20.4. Yes, option 20.4 is there. Option B. So I can do it, no, like 20, 40 divided by 100. So 10, 10 cancelled. So one more 0 left out. So 20.4 centimeter is the height of the water. Okay, height of the water limbs. Right now, so this is how you will do the questions whenever they ask based on the U tubes, like U shaped tubes. Okay, yes. So if you got it, we can go for the next question. Yeah, I'll go for the answer slide. Yeah, you can see them. If it is completed, we can go for the next question. Can we go for the next question? Yes. So the next question is, a bullet of mass 0.25 kg moving horizontally with velocity meter per second. Strikes a stationary block of mass 1 kg suspended by a long inextensible string of a negligible mass and length. The bullet gets embedded in the block and the system rises up to the maximum height of the height is given, that is 19.6 centimeter as shown in the given figure. The string still remains taut. The value of initial speed v of the bullet is, okay, the one thing what we can understand is there is some initial momentum after hitting that it has been moved to some height. So there will be some momentum. No, so initial momentum should be equal to the final momentum. That concept we should keep in mind. So bullet of mass, that is m is equals to 0.25 kg. Okay, block mass is, that is 1 kg I have written. So height raised is 19.6. No, so 19.6 in the sense centimeter. No, so 19.6 into 10 power minus 2. No, which is nothing but 1.96. Done. 0.96. No, yeah, 0.196 meter. That's it. So 0.196 meter. Now what I should do? The thing is I need to find the energy at maximum height. So energy at maximum height in the sense like the bullet mass plus the mass of the block going to some height and store some energy. Right now store some energy. So V, yes, just after collision, no, after collision in the sense like kinetic energy should be equals to potential energy, no, kinetic energy plus potential energy, no. So kinetic energy means what? Of mv square is equals to mgh. Here m and m will get cancelled. V square will be equals to 2gh, where v will be equals to under root of 2gh. That's what we have written here. Okay. So in this, what I can find? The velocity, the final velocity, right? So what is the final velocity? Here 2 into 9.8 into 0.196. Done. 0.196. So what I will get here in this case, 9.8 into, yes, so under root of 9.8 into 2 is 19.6, right? Yes, 19.6 into 0.196. So in this one I can write like this, no, 196 into 196 divide by how much? 1 0 1 2 3, so I mean 1 point and 4 points, so 10 power 4, 10 power 4. So 196 square, no, under root of 196 whole square, or I can write like this, 196 divided by 10 the whole square. Fine, 10 power 2 the whole square. Okay, 10 power 2 the whole square. So square and root will get cancelled out. So 196 divided by 10 power 2, which is nothing but 1.96 meter per second. Done. This is my final velocity. Now the initial thing I need to get it. So initial thing in the sense, so mass into velocity, momentum. So initially some mass is there, that is bullet mass, should be equals to mass of the bullet plus mass of the block into the velocity. So V should be equals to capital M plus small m into V dash by V, sorry, V dash by M. So what is the block of, I mean mass of block 1 kg, bullet mass is 0.25 kg. Okay, so 0.25 I will write here, 1.25 into how much velocity is given? 1.96, right? 1.96. So if I calculate this, I will get the velocity of the initial, that is bullet's velocity. Fine. So only thing is 1.25 into 1.96 divided by 2.25. If I calculate this one, no, we'll get the initial velocity of the bullet. So note the point, I need to find the velocity, that is final velocity, by using the energy at maximum height. So initial, like kinetic energy should be equals to potential energy. So why we have taken here like mass and mass be cancelled, like this mass, no, can be written as capital M plus small m, the total mass of the system. Okay, done. If it is completed, we can go for the next question. Yeah, you can give the answer and we'll go for the next question. Yes, we'll go. Okay, so the next question I'll give a hint. Okay, I'll give a hint here. So you are given three resistance of value 2, 4 and 6. Which of the following value of equivalent resistance is not possible to get by using the arranging these three resistors in any circuit? So I'll give a simple hint here. So what they have said here, equivalent resistance is not possible by using any arrangement, no. So any arrangement in the sense, this 2 ohm resistance, 4 ohm resistance and 6 ohm resistance are there. So first thing, R parallel I can find and R series I can find, no. R parallel I can find, R series also I can find, no. So yes, R series. So by using these two, I need to find which is the not possible equivalent thing. Okay, so you can take this as a homework question and give answer in the comment boxes. Whoever watching in online or offline, whoever watching in offline now can give answer in the next session, and online people can give answer in the comment boxes, guys. Okay, so we'll see some more question in the upcoming class of NSEJS. Okay, so stay tuned for the classes, so don't try to miss the classes. Okay, okay guys, bye bye, we'll meet in the next class.